Today we're going to start Conceptual Unit 4. We're going to be talking about polynomial functions in this unit. We're going to start with functions and their graphs and talking about whether they are even or odd and whether they have, and to describe its end behavior. Alright, so definitions of even and odd functions. The function f is an even function if f of negative x equals f of x. What that means is that you're going to replace every x with a negative x in the function. If none of the signs change, if nothing changes when x is replaced with negative x, then your function is even. Another way you can look at it is to check some ordered pairs. If xy is a solution, like this one right here, if the function is even, then if you just change the sign of x to negative x and y, it also has to be on the graph in order for the function to be even. Okay, so they took a real point right here, 3, 5, and notice if they change the sign of x, it'd be negative 3, 5. If I check to see if it's on the graph, it is, which means you have even symmetry, which means it's an even function. Okay, the function f is an odd function if f of negative x equals negative f of x for all x in the domain of f. What that means is that if every term changes signs in the function after you replace x with negative x, then the function is odd. You can also look at some ordered pairs. For example, this ordered pair xy, if I change both of its signs and see if it's on the graph, it is. If it is, then it's an odd function. If I take a real point, 2, 8, and I change both signs and check to see if it's on the graph, sure enough, it is, which means the function is odd. Okay, so it says determine whether each of the following functions is even, odd, or neither. So what they want us to do is to find f of negative x. So all I do is copy the function, but instead of plugging in positive x, I'm going to plug in negative x, and I'm going to see what happens. This negative x cubed is negative x times negative x times negative x. This is positive x squared times that negative x makes negative x cubed. Distribute here, that makes positive 6x. So if I look at the original function and I see if either they all changed signs or no one changed signs. X cubed started out positive, now it's negative. 6x started out negative, now it's positive. So every sign changed, which makes it an odd function. Okay, then it says check the function on a grapher, sketch the graph, and describe the end behavior. If I type it in the graphing calculator, you go to y equals, type in x cubed minus 6x, you should get this graph. Okay, if I look at it, guys, there's a couple ways you can tell. If you just take this right hand side, okay, and you flip it over, upside down. So if I flipped that over, it would look like this, right? And then if I take that and reflect it this way over the y, it would look like this. So after my double reflection, in other words, I took half of the graph, flipped it upside down or upside right, whatever, and then flipped it over, if you have to flip twice, down and over, then the function is odd. Okay, you can also tell by looking at a table of values. If you've got, while you got this graph, you can go to table and you look at it lists some ordered pairs for you. Pick any one. If I pick negative 3, negative 9, if this function is odd, then positive 3 and positive 9 will also be on the graph. So if I check my ordered pairs, is positive 3, positive 9 on the graph? It is, so that also confirms that it is an odd function. Okay, the other thing, they want us to describe this end behavior. Alright, this is kind of starting you getting just a little taste of calculus. Okay, what we're going to do is we're going to find the limit as x approaches infinity, and we're going to find the limit Let me use a different color. And we're going to find the limit as x approaches negative infinity. And what you do, guys, positive infinity is this way. Positive infinity on x is here. And so as I look this way, I'm looking at the rightest part, the rightest tail, if you will. The ends are tails. And this tail on this side is pointing up. What that means is, as x gets bigger and bigger, so does my y values. So the limit as x approaches infinity, all you do is look at the direction of the arrow that's on that side. If it's pointing up, then that says the function, or the y values, are going to infinity. To do the limit as x approaches negative infinity, I'm looking this way, because this way is negative infinity on the x-axis. And all you do is look at the direction of the tail on that side, which is pointing down, which says, as I pick smaller and smaller x's, the answers I get are smaller and smaller y's. So the function values, the y values, are heading also to negative infinity. There's your end behavior. Okay, let's try some more. Determine whether each of the following functions is even, odd, or neither. Algebraically, if I find g of negative x, which means I copy my function, but I'm going to replace all of the x's with negative x's, and I simplify, this would be 4 copies of negative x. Okay, a negative times a negative is a positive. That's x squared. Bring down the next one. Times negative x makes negative x cubed. Times negative x makes positive x to the 4th. You got to do this first. So this says negative 2 times negative x times negative x. So this would be, again, if you go left to right, this would be positive 2x. And then bring down this times negative x makes it a negative 2x to the 2nd. So if I compare that, there's g of negative x. If I compare that to my original function, g of x, which was x to the 4th minus 2x squared, notice that in my original function, x to the 4th is positive. In my g to the negative x, x to the 4th is also positive. In my original function g, my x squared term is negative, and in my g of negative x, my squared term is negative. So no signs changed. No signs changed. And when no signs change, that means your function is even. Okay, that's algebraically. We can look at the graph to make sure. And it's, again, the way you check for even symmetry is you copy 1/2 of the graph and just reflect it. If it's even, it will reflect over y. If I reflect it this way, it would land right on top of the yellow, would land right on top of the orange. So since I can take half of the graph, fold it over the y-axis, and it lays perfectly on top of the left-hand side, my function's even. Notice that the y-axis cuts the function in half. Your function does not have even symmetry unless the y-axis cuts it in half. Okay? So we have to describe, I also, can check the table of values. For an even function, when you pick an xy, then negative xy also has to be on the list. So if I pick any of these ordered pairs, I'm going to pick negative 363. In order for the function to be even, if negative 363 is on the function, if it's even, then changing the sign of x, positive 3, leave y alone, also has to be on there. If I check to see, is 363 on there? Yes, it is. And you could also do it algebraically. You could substitute them in. Okay, so that's another clue that this is even. And then they want me to describe my end behavior. Well, if I look at my graph, when I go to the right, this arrow's pointing up, which says the limit as x approaches infinity, the function approaches infinity. As I pick bigger and bigger x's to plug in, I get bigger and bigger y's. Okay, for the limit as x approaches negative infinity, you're going this way, and you're looking at the arrow which is also pointing up. So the limit as x approaches negative infinity, my function is approaching positive infinity. If I pick lower and lower x's, I still get higher and higher y values. Okay, so there's our end behavior. Alright, another one, if I find h of negative x, I'm going to copy my function, but I'm going to replace all of the x's with negative x's. This would be negative x times negative x, which makes positive x squared. This is going to be negative 2x, and this is going to be positive 1. There's my h of negative x. My original function, h of x, is positive x squared, negative 2x, positive 1. If I look to see what signs changed, alright, alright, I'm checking those signs. Just a second here, fix my proofs. This was a positive, this was a positive, negative, negative, positive, positive. Oops. There's my pen again. Alright, so if I look at the signs, didn't change. Sorry, that was a plus too. Did change. So didn't change, did change, didn't change. So some did, some didn't, which makes it neither. And if you notice on the graph, if I draw this half of it and reflected it over on the other side, it would look like this, which does not land on top of the left-hand side on my graph. So it's not even, and obviously it's not odd, because if it was odd, it would have to turn upside down and then reflect over, which it also does not. So it's not even and it's not odd. And you can look at an ordered pair. If I look at negative 3, 4, if this function was even, then positive 3, 4 would have to be on the graph, and it's not. If it was odd, then positive 3, negative 4 would have to be on the graph, and again, it's not, so it's neither. My end behavior, both arrows are pointing up. So as I go to positive infinity and I go to negative infinity, the functions are going higher. So the limit as x approaches infinity, I'm looking on this side, the arrow's pointing up, which says my function is going to infinity. My limit as x approaches negative infinity, again, as I go left, the arrow goes up, so that means the function is going to infinity. Okay? Alright, if we do x squared plus 6, if I find f of negative x, I would have negative x squared plus 6. This is negative x times negative x, which is x squared plus 6. There's my f of negative x. If I take my original f of x, which was x squared plus 6, and I compare signs, both positive, both positive. So no signs changed. Oops. Sorry. No, the sign didn't change. No, the sign didn't change. Since no signs change, this function is even. Graphically, I can look at it and you can see that if I drew the right-hand side and I reflected it over, it would land right on top of the left-hand side, which means the y-axis cuts it in half, which, yes, means that it's even. I can also check a table of values. If I pick a point and test it, let's say that I pick negative 3, 15, for it to be an even function, you would change the sign of x and see if it's on there. And I look, and it is, which confirms its evenness. And then behavior, both arrows are pointing up, so the limit as x approaches infinity, the function is getting higher, so the function is approaching infinity. As I go to the right, the function is going up. As I go to the left, which is the limit as x approaches negative infinity, the function is again going to positive infinity. And there's your end behavior. Alright, let's try another one. If I find g of negative x, I get 7 times negative x cubed minus a negative x. Sorry, and I'm not changing colors anymore. I took out the x's and replaced them with negative x's. Now, when I do the math, guys, this is 7 times 3 copies of negative x. Distribute here is a positive x. This is going to be negative 7x times negative x is positive 7x squared times negative x is going to be a negative 7x cubed, and that's going to be a plus x. There's my g of negative x. If I compare that to my g of x, which was 7x cubed minus x, and I compare signs, negative turned to positive, positive turned to negative, so all signs changed, which means my function is odd. Okay, graphically, I can check, and again, if I can draw the right-hand side, reflect it upside down, and reflect it over, then it's an odd function. And you can see the yellow went down to yellow, then flipped over to orange, and it redrew half of the graph. So yes, this is an odd function. I can also check my table of values. If I look at this ordered pair, -3, -186, and I'm checking to see if my function is odd, change both signs, 3 and +186, and check the table. If that point is on there, then it proves that my function is odd. Okay, now for end behavior, this arrow's pointing up, this arrow's pointing down. Alright, so as I go to positive infinity, my function is going up, and as I go to negative infinity, my function is going down. So we say the limit as x approaches infinity, my function is going up, which is towards infinity. The limit as x approaches negative infinity, my function is going down, which means my function is approaching negative infinity. And there's your end behavior. Alright, so let's do this one. Alright, if I find h of negative x, I get parentheses 5 plus 1. Replace the x with negative x and simplify. This is negative x times negative x times negative x times negative x times negative x plus 1. This is x squared times this negative x is negative x cubed times this negative x is positive x to the 4th times this negative x is negative x to the 5th. And the plus 1 comes down. There's my h of negative x. If I compare that to my original function, h of x, which was x to the 5th plus 1, and I compare signs, did change, didn't change. So some did, some didn't, which makes this neither. This would be neither even nor odd. Okay? Alright, so if we look at the graph, you can tell if I tried, my instinct was maybe it's odd, but if I try and reflect twice, if I draw this half and turn it upside down, it's going to be, what was that at 1? It's going to be down here. And then if I reflect it over the y-axis, it's going to turn like this, which did not draw the whole other side. So again, it's neither. Alright, now to describe, oh, and you can look at an ordered pair too. Okay, if I look at -3, -242, if I'm checking for even, then 3, -242 would be on the table. And it's not. If I was checking for odd, then 3, +242 would be on the table. Close, but it's not, so it's neither. End behavior, this arrow is pointing up, this arrow is pointing down. So as I go to positive infinity, my function is going up. And as I go to negative infinity, my function is going down. So to write that up, we say the limit as x approaches infinity, my function is going up, which means it's heading towards infinity. And to describe this side, you say the limit as x approaches negative infinity, the function is going down, which means it's approaching negative infinity. Okay? Alright, you try, hit pause, come back when you're ready. And hopefully you got even. Algebraically, f of -x equals 4x squared plus x to the 4th, but I'm going to change all my x's to negative x's. This would be 4 times 2 copies of -x plus 4 copies of -x. And again, you don't have to write all this out. I just don't want to lose anybody by doing it in my head. This would be -4x times -x is positive 4x squared. This is going to be a positive x squared times my -x is going to be a -x cubed times this -x is going to be a positive x to the 4th. So I have plus x to the 4th. That's my f of -x. If I compare that to f of x, which was positive 4x squared, positive x to the 4th, and I compare signs, positive, 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 no sign changes, no changes, dang it, no changes, which means if nobody's changed signs, it's an even function. Again, don't forget, you can check by the graph and by the table of values. This half lies on top of this half. -3, 117, just change x if it's even. It's positive 3, 117, it's on the graph, so it checks. Okay, do this one, hit pause, come back when you're ready. And again, hopefully you got odd. Algebraically, f of -x equals -5x to the 5th plus x cubed. But I'm going to replace all my x's with negative x's. This is going to be a -5 times a -x times 2, 3, 4, 5 x's plus 1, 2, 3. So, a couple at a time, this is going to be positive 5x times -x is going to be -5x squared times -x is going to be positive 5x cubed. Bring down times -x is going to be -5x to the 4th times -x is going to be a positive 5x to the 5th. Okay? Plus -x times -x is x squared times this -x is -x cubed. Alright? Right. So altogether then I have 5x to the 5th minus x cubed. That's my f of, negative h. Compare it to my f of h, which is 5x squared plus x cubed, and I compare signs. Positive stayed positive, negative turned, oh sorry, the original was negative. Freaking. Okay, the fifth degrees, what the heck am I doing? The fifth degrees change signs and the cubes change signs, so all changed, which makes the function odd. You can look at the table in the graph. If I check an ordered pair, negative 3, 11, 88, and I'm checking to see if I'm right and it's odd, that means both signs would change, 3 and negative 11, 88. Check the table, is it on there? Yes, then it's odd. Alright, try this one, hit pause, come back. Hopefully you got neither. Algebraically, if I find f of negative x, I get x cubed plus x squared plus 4. But I'm going to plug in a negative x. And now let me see if we can do a little shortcut instead of writing all this out. You're going to have 3 copies of a negative multiplied together. If you have an odd number of negatives, then I promise it will come out negative. Alright, and then you have, what is that? What's that? And then you have 3 x's multiplied together, which makes x cubed. Here you have 2 negatives, an even amount of negatives, which is going to turn positive. Because a negative times itself is positive, and x times itself is x squared plus 4. There's my f of negative x. If I compare that to my f of x, which is positive x cubed, positive x squared, positive 4, and I compare signs, these did change, these did not change, these did not change. So it's neither. You can also tell, again, from the picture in the graph, if I was trying to redraw this, it's not even because it doesn't reflect over y. And it's not odd because that would go down to here and then flip over and it wouldn't be on top of the other one. Okay, so I know it's neither. And then table-wise, you can tell if I choose a point, negative 3, negative 14, to be even, it would have to pass through 3, negative 14. And it doesn't. It crosses through 340. Okay. If I wanted to check for odd, I'd have to change both signs. So change to 3, positive 14. But again, that's not the point either. So it's not even or odd. Alright, symmetry. It's the same stuff. Basically, you're just, if it tells you it has even function, if it's an even function and it has y-axis, then it has y-axis symmetry. Meaning the y-axis has to cut the function in half. And again, all you're going to do, they're not even going to give you an equation. They're just going to give you x, y coordinates. They're going to give you a graph. You're going to pick x, y coordinates off it, and you're going to see if it's even or odd. You're going to change the sign of just the x and see if it's on the graph. If it is, then it's even. If it's not, then it's not. It doesn't mean that it's odd. It just means that it's not even. So if it's not even, then you'd test to see if it's odd, which means you would choose a graph and change both of the signs and then see if that's on the graph, and if it's yes, it's odd, and if it's no, it's not odd. Doesn't mean it's even, just means it's not odd. Okay, so it says use possible symmetry to determine whether the graph is the graph of an even function, an odd function, or a function that is neither even nor odd. Then describe the end behavior. Alright, some of these it gets a little, I mean, guys, I can tell that this one's odd. Because, again, by drawing. If I took this half of the picture and I reflected it down and then over, I get the other half of the graph. That's a double reflection, which makes it an odd function. What they want you to do is to pick an ordered pair. I'm going to pick this one right here, and I'm going to eyeball it and call it 2, 0.5. I'm guessing odd, so I'm going to prove it by changing both of the signs, negative 2, negative 0.5, and seeing if that is also on the graph. If I go to negative 2, negative 0.5, it lands on the graph and to positive 0.52. Okay, that makes it an odd function. Okay, again, on B, the y-axis is cutting the parabola in half. When your y-axis splits your picture in half, I promise that's even symmetry. To check it with a point like they want us to, I can pick any point I want. How about I pick, let's pick 4, 9, 10, 4, 10. Okay, so if I pick that ordered pair, and I'm guessing it's even, so check, just change the sign of x, and check to see if it's on the graph. If I go to -4 and up to 10, is it on the graph? Yes, which makes it even. Okay, and then if you look at the third one, that one's a neither one. I can tell because if I tried to redraw this half upside down, it would be down here, and then reflect over would go over this way, and that's not drawing this, so it's not odd. I can tell it's not even because the y-axis doesn't cut it, so I'm going with neither. Now I got to prove it with an ordered pair. Well, if I pick any ordered pair, let's pick 4, 0. If I want to check for even, change the sign of x. -4, 0. -4, sorry. Wow, Miss Hamilton. That point is 0, 4. So to change the sign of just, well, I guess you shouldn't pick 0 because you can't change the sign of 0. 0 is neither positive nor negative. Let's pick a different point. How about I pick 2, comma, looks close to 10. So if I pick 2, 10 and I want to check, pick 2, 10 and I want to check for even, I would change the sign of x and see if it's on the graph. -2, positive 10. No, that's not on the graph, so it's not even. If it's odd, I'm going to change both signs, so I'd have -2, -10. And if I tried to graph that, -2, -10, close, but not, so it's not odd, which means it's neither. Alright, you try one, hit pause, come back when you're ready. It is even. I can tell because the y-axis cuts it in half. This side, if I draw it on the other side, will lay right on top of it. But if you pick an ordered pair, 4, 10, and you're checking for evenness, so you change the sign of x, -4, 10 is also on there, so it is an even function. Okay, do this one, hit pause, come back when you're ready. And I hope you got neither. If I pick an ordered pair, let's go with 2, 10. It's the same graph. Oh my goodness. 2, 10, and I think it's, if it was even, the -2, 10 would have to be on the graph. It's not. If it's odd, then -2, -10 would have to be on the graph, and it doesn't hit it. So it's neither. And hit pause, come back when you're ready. And hopefully you got odd. Again, I can tell it's odd because if it reflects diagonally, in other words, whatever's up here is also over here, alright, then you have an odd function. But if I check an ordered pair, let's check, 2.5. For odd, change both signs, and that has to be on there. -2, -0.5 is, that's odd. Alright, so describe the graph of a polynomial function. Well, it's a smooth, continuous curve. 2, given a graph, how do you describe its end behavior? Let's put that down here. You look at tails. As x approaches infinity, Then you look at to see if the tail is pointing up, then the function goes to infinity. As you go to infinity and the arrow is pointing down, that means the function goes to negative infinity. If it's the other way around, if as x approaches negative infinity and the arrow is pointing up, that means the function goes to infinity. As x approaches negative infinity, if the arrow is pointing down, that means the function is going to negative infinity. Okay? And these two are kind of related, but we're going to get to this one tomorrow. Alright, and we are at homework, so we are done. Happy homeworking, and I will see you next time.